Thank you. Thank you. No, actually, it is the right time now for discussion and questions because we completed the short talks. So I invite the attendees to bring their questions forward or any comment. I'm also keeping an eye on Discord. I see a little bit of discussion in Discord about the biohybrid, but unfortunately, we cannot have a first speaker with us. Okay, so I see Josie put in a question. So what do the different panelists think of these two approaches that Tom proposed? So who wants to start with an answer?
Maybe I can jump in. So this is what do we think about the approaches that Tom proposed? Is that right?
Yeah.
Yeah. So I would say I'm a relative amateur in, of course, these debates because ultimately I'm a psychologist interested in human interaction with a kind of side gig in informing the design of digital agents. And I'm sensitive to the face the facts argument because I totally see the argument that some of these things need to be separated. Expectations need to be managed. I think that's probably the what underscores these arguments. You know, in terms of our own work, the facial movements that we can model don't even really need to be displayed on a human or humanoid face. It's really about, and can be done with any stimulus display. This is the kind of power of the approach that we use. Essentially, the approach is that we want to know what's going to elicit a particular perception in a human. So if it's that it's a trustworthy facial movement of happiness well displayed on an artificial agent of any form, then we can do that with this particular technique. The examples I showed you here were from psychology for human interaction. So we're very much about human face shapes, complexions, and movements. So from my perspective, being something of an outsider, I understand the arguments of the face the facts approach.
I could maybe add that, I mean, I on the slide, since it was a short presentation, I presented it as two wildly different options just to stimulate some discussion. You can, of course, say that in practice, they're not necessarily, you could combine them. I mean, and they don't necessarily exclude each other. I mean, if we just take the examples that Rachel talked about, and sorry, Rachel, to always take your cases as the example, but since you just talked about it, I mean, the virtual agents that she showed, they are obviously not real. So nobody, I hope, could confuse them with a real person. And I always, as the example I usually use is Donald Duck. I mean, if you look at the Donald Duck movie, there's all sorts of psychological realism in there, but that's of course no problem because nobody would interpret Donald Duck as a real person. Or think of some cartoons like Tom and Jerry. I mean, they're very predictable because they're human-like in many ways. But everybody understands that that's just a cartoon. So the thing that I'm more worried about is things like self-driving cars, because people don't know, because self-driving cars are not just a cartoon. They're not Donald Duck. They're not a virtual agent, but they're in the real world, and people have to interpret them. And people need to understand that self-driving cars don't have the same cognitive capacities as humans have. So it's the argument is more relevant in that case, where the type of confusion that I talked about can have practical, and in that case lethal relevance. And the argument doesn't apply so much to the type of virtual agents that Rachel showed, because in that case it's more obvious that they are not human-like.
may I add a question, comment on this topic? Because what we also learn in robotics from neuroscience is that the human brain is very good at making predictions. So as you say, we can predict quite easily the behavior of another human being, either driving a car or moving around in the street. But we can also learn quite quickly to predict the behavior of other agents. So you mentioned dogs, for example, and we can actually, after a little while, learn and create our internal models of the behavior of the dog and can do some predictions. So maybe when it comes to robots, if they are really human-like, as you say, we expect a similar behavior. But if they are not human-like, it's difficult to predict their behavior, but at some point we can learn it. What do you think? I mean, any human being can create an internal model after a little bit of observation and interaction with the robot. Does it make sense?
I think it does make sense. And of course, in, let's say, 20 years from now, we will all be used to self-driving cars and we know what they can and what they cannot do. But the interesting question is, of course, the transition from now to, let's say, in 20 years or so. And now, I mean, we have a self-driving bus on campus, which moves very slowly, and people do get used to it, of course. But the question is, I mean, there's always a first encounter, and the problem with self-driving cars is if I buy a self-driving car, you're the ones who have to interact with it potentially. Whereas if I buy a robot lawnmower, it's my problem or my cat's problem. Whereas if that's my standard example. If I buy a self-driving car, you might encounter it and you will need to be able to interact with it, and you will need to be able to interact with it already the first time you meet it. And it's not just you, because you're all moderately techie people, but also 5-year-olds and 95-year-olds will need to be able to interact with it. So that's the real problem.
I see a question about the disgust, the expression for disgust. So the question is it something useful to put in a robot?
I guess it depends a bit on what the robot's being used for. I think a lot of these conversations are, it's horses for courses. What is it for? What's the purpose? And then, the design follows from the function. So I think it can depend on what the agent is being used for. It could be to warn people. So for example, if you wanted to have a warning system for people to stay away from certain poisonous things in the environment or something else that would be dangerous, then the facial signal of disgust is very powerful to the human brain. So it's fairly universal, but probably because of its visceral connections. You can also have other agents present disgust facial expressions and say moral disgust, which is slightly different to visceral disgust, and the facial expression is also a bit different. And this could be used, for example, in training social skills, for example. So I can see lots of different applications where facial expressions of disgust would be important or would be useful to equip a digital agent with the idea, of course, got to take Tom's point earlier about it wouldn't be believable that an agent would feel disgust, but what the agent might be doing is signaling disgust, saying stay away from this, or this is something wrong that you're doing, even if it doesn't have any moral compass. So I can see a lot of different applications where that would be possible, yeah.
Okay, then there is a question on, for me actually, on the modeling of the external interactions that we want to use for designing robots that take them into account. So the question is more specifically what we want to model. It's the interaction, which means the forces that we expect that the robot will receive from the environment. But this is not just for compensating them, as we usually do in robotics, but it is for using them. So ideally, we should design our robot. We know the movements we want in our robot, and we should take these interaction forces into account to help our movement. This is more or less the idea, and Justin is following up about what are the limitations. I mean, just technical or fundamental. Actually, for sure, there are important technical limitations, because it's really difficult to really take into account all the interaction forces and all the possible ways of interaction with the environment, solid, fluid, whatever. And especially if we, as I mentioned, if we want to enlarge a little bit the ecological niche in which our robots, so with embodied intelligence, can work. I hope I answered. There is something else about the human body niche that actually changes as we adapt. But the question is on the social expectation. So it's probably similar to my comment. Tom, can you read the question in the chat box? I can read that for you.
Yeah, and I think it's the question I think we addressed it a couple of minutes ago. Of course, people will acquire different social expectation when it comes to robots. So, and to some degree, this is also related to there's a question a little higher up. Should self-driving cars not look like other cars? And in response to that, of course, you could give two different answers, and then those are very clear also in the self-driving vehicle community. Some people, I personally would say, yes, they should not look like other cars, but they should have like a big red light flashing on top or so that people know they're interacting with something else. But there are people who argue the exact opposite, who would say that, no, artificial self-driving cars should act exactly like normal cars, because that's what people know how to interact with. So for somebody, for a pedestrian or a bicyclist interacting with the self-driving vehicle, they shouldn't have to know what exactly the level of automation is that the car has or doesn't have. They should be able to interact without that knowledge. So also in that little to that little question, you can also give the two different answers that I was trying to sketch at the end of my talk.
Another comment on the same topic is about the uncanny valley, which is probably relevant in this discussion. This is probably what can generate the trigger.
Yeah, and in terms of the uncanny valley, very simplistically, I would say, let's stay away from the uncanny valley. Let's move to the left. And other people would say, well, we have to cross the uncanny valley.
Yeah, exactly.
So that's it's just the two different directions you can go.
Exactly. Someone, I mean, is aiming at going on the other side and having robots completely similar and to human beings. I'm also intrigued by the spider case that was presented. Spider and web. So is the web, can we consider the web as a part of the embodiment of the spider, or is it the environment of the spider?
It's like a sense organ, but so I think it's relates to the sort of like informational coupling to the environment. And so in your talk, you talked about the mechanical interaction between the environment, but something like informational coupling to the environment is really important. In the previous two talks about the interpersonal information is really related to the nature of information that humans are coupled with. And the spider case is also about the informational coupling, and which is the sort of the aspect of the dynamics of environmental interaction that we should take into account in the more seriously, I think.
Thank you very much. That's extremely interesting, I think, for embodied intelligence. So I don't think I see any other comments. And in Discord, there is a little bit of discussion on the biohybrid case, but probably we cannot comment too much on that. Oh, yes, another question. I wonder why we need to make the decision about whether it is part of the body. Okay, you consider the bike part of the body. Given bike, I will not. Yeah, it's a nice comment in the chat box. Yeah, but for me it is relevant because it is part of the embodied intelligence concept. And by the way, we started with the questions. I wanted to actually ask each of you about your let's say definition, but I'm not meaning a formal definition, just what embodied intelligence is for you. That's one of the main goals of the conference, to have and compare different possible definitions. And since we are all from different fields, basically we have different ideas. So I just recalled my interpretation, my meaning of embodied intelligence in the beginning, which is just functional, instrumental to robotics and the way we can build and control robots. But of course, I see in your talks and your comments that you have a bit different ideas of embodied intelligence. So it would be nice to, who wants to start?
So can I say
Sure.
something? So to me, it's like to take the sort of perspective seriously. So if you take if you do not take into account our body, so everything is like God eye, the bird's eye view, and everything is like something that is objective. But as soon as you have a body, your perspective is limited by your configuration of body and your movement and everything. So to me, it's like embodied intelligence. What appeals to me is to take seriously about the perspective you have because of having your body.
Okay, so it's a sort of a way to, let's say, not limit, but instantiate your intelligence into a real world and the real.
Right.
Okay, yeah. Tom or Rachel?
I think it's a very complex question. I mean, I've probably written like 10 papers or so about different notions of embodied cognition and embodied intelligence. So I'm not gonna talk about those 10 different notions here, but for me personally, it's always been, since I'm a cognitive scientist with a computer science background, what's always been interesting to me is that in this field of embodied intelligence or embodied cognition, there are at least two radically different notions of what it means to be embodied. And one is the that I talked about under the heading of symbol grounding, the idea that the key point about being embodied is being physical, being in the world, being able to have, to interact with the world. That notion of according to which then human-robot interaction should be relatively unproblematic, because robots are, you could say, in the same physical world as we are, and then they can learn about the world and so on. But on the other hand, there's that notion that comes from Varela and colleagues, for example, the embodied mind from '91, according to which cognition is very much grounded in biological mechanisms, and from that perspective, of course, they're still, although our robots are in the world, they're certainly not in the world in the same sense that we are, because they don't breathe, they don't eat, and so on. So yeah, as we discussed with the discussed example earlier, so although they are embodied in the physical sense, there are many other senses in which they are not embodied. So I think that's a long way of saying that it depends on how you define it.
Okay, I guess I'll go now. So I'm a psychologist. I certainly don't speak for all psychologists, but I'm a psychologist who comes from vision science primarily, and vision scientists, much like, I guess, ethologists, are quite obsessed with characterizing signals. And so I really tend to think about embodied intelligence, or embodied social intelligence, which is what I'm, really focused on, is how that is really signaled by individuals. And of course, that is signaled via the body, via different modalities. And so it's really the expression of that intelligence, broadly stated, via multi-component and multimodal signals. But it's more than just how the body could signal these things, because of course there's a lot of limitations, physical limitations, as mentioned before, about the many ways in which the body could signal information, because all of these signals are designed in reference to the bodies of receivers. Of course, it's the same bodies, but in terms of visual signals, of course, these are designed in reference to the visual capabilities of human receivers. So it's embodied in that sense, in a kind of indirect way, where we know that the signals that are produced by expressors are intrinsically linked to the perceptual capabilities of their receivers, in addition to the environment. So, for example, if one needed to express an emotion across a longer distance, then it's very unlikely that you would use the face, because it's not very visible over long distances. You would need to use another modality, such as shouting, which carries across long distances, and so on. So these choices of the components and the modalities, as well as the physical form, is co-evolved with the capabilities of the receiver as well as the expressor. So I really think about it in a framework which is very, very similar to how ethologists might think about it, if you like, really about how signals are designed to suit their purpose, and how they're designed within the physical environment and cognitive environment, if you like, where the environment includes lots of other human brains and cognitions and bodies.
So I think we all agree that we cannot really develop intelligent agents inside a computer only. They need a physical body, right? So they are robots. But at the same time, we see there's a hype in artificial intelligence, which is basically just computation, just inside a computer. So how do you see that? I mean, it's just a matter of, let's say, time, progress, and we will eventually progress towards more embodied machines, or is it more like a fundamental issue? And don't know why, but we are mostly, or maybe more comfortable with the computers, with computation only, with something that it's just behind a screen and doesn't have a body.
I happened to notice that in one of the breakout sessions, which I guess are going on right now, somebody has the talk title, is ChatGPT really disembodied? And presumably the argument is, obviously I missed the talk now, but presumably the argument is that ChatGPT does learn and so on. And in that sense, presumably also could be considered embodied, but I mean, that's what we just said a couple of minutes ago. There's so many different notions of embodiment that, yeah, it's difficult to have strong opinions on that. Personally, I agree to what you just said, Cecilia, about the hype. Obviously, it's hype, and 20 minutes ago somebody mentioned the term expectation management, and that's an important term here, and that's what's lacking in AI currently, I would say.
Yeah, there are comments for that. Actually, if I'm not wrong, the breakout sessions will start in 10 minutes, right? I ask.
Okay. Sorry, I got confused between Swedish time and British time. So the guy just pointed out in the chat that his talk is, of course, starting in the session that starts in 10 minutes. Sorry, got confused.
Yeah, okay. I was also a bit scared because I thought I was making a mistake with the program. But okay, so good. We will so we can attend also that session. So actually, we have about 10 minutes left. Do you want to add some sort of conclusive comments? I don't see any more questions appearing. Discord is also quiet, at least in the panel discussion number 1.
Cecilia, I think there are lots of questions in the questions to the speaker channel of Discord.
Okay, because I am in the panel number 1, so I don't see it. And discussion number 1. Do you want to put them forward?
Yeah, I think I can read out these questions. So there's one person asking, do we actually need to choose between making AI more human-like or face the facts could implement social cognitive abilities in AI systems? I think it's similar related to the how embodiment and disembodied AI related to each other. So maybe we can start from there.
Okay. Wants to go on replying. So maybe either Tom or Rachel can.
So the question is, do we need to choose? I mean, Tom can probably talk about this more intelligently than I can, but I would tend to say it's horses for courses. You know, what do you need it for? What's it for? And then you can decide whether it's really necessary or not. You know, performance art, do you want it to look human? Yeah, if you want it, it's a piece of performance art which needs to be human. And you know, I've certainly seen some of these creations which is, you know, making big contributions, conceptual contributions in many different ways. So for me, it's a horses for courses thing. But Tom has more nuanced views on that, I think.
Actually, Tom missed the question because he was reading the questions in the chat instead.
Yeah.
Sorry.
I'm trying to keep up with Discord, but it's a bit too complex to look at the different.
So the question, Tom, is: do we need to choose? Do we need to choose between the two, between face the facts and make them more human?
No, as I also tried to say earlier, I think you don't necessarily have to choose, but that term of expectation management that we've mentioned a couple of times now is crucial there. As I said, I mean, whatever it is that makes it clear in the case of the virtual agents that Rachel talked about, it is clear to us that they're not human, right? I mean, and nobody would confuse them with something that is really human. I would say. On the other hand, you could say, I mean, okay, some people will be talking about ChatGPT. I mean, if some of you have probably read that piece somebody wrote for the New York Times about talking to ChatGPT, or the other one, the Bing version of it, and they apparently did get confused when ChatGPT talked about how the reporter should leave his wife and get together with the chatbot instead, and so, or at least the reporter pretended to get scared by that. So yeah, I don't know. It's a difficult question, but I personally think you don't have to choose. You can make agents more human-like, but you have to be clear about that they're not human-like, and that's not necessarily a contradiction. I recently wrote a paper about this where I talk about the suspension of disbelief and the suspension of belief, because that's what required here in order to understand, for example, Donald Duck, is that you have to suspend your disbelief that a duck or even an unanimated duck can have human-like mental states. But at the same time, you maintain that capacity to suspend your belief, because so you can interpret Donald Duck as a person, and that makes the story very funny. But you can also take back that interpretation, and you can say, yeah, but really Tom and Jerry are hitting each other in the face with frying pans or doing something like that. But obviously they're not human. So this is not. So it's easy for us to interpret that type of cartoon characters as both human-like and not human-like at all at the same time. And I think that's what we need in the case of robots also.
Can you see the question? Why is that? Tom and Jerry look more real than Polar Express.
That has to do with the uncanny valley, right? Isn't it? I don't think they look more real, because they look, of course, less real, but they're in the wrong position on that uncanny valley graph, I would say.
Yeah, maybe, I mean, related to that, I think it's Rachel's work on the facial expressions, because I think that, I mean, the work is amazing because you really found amazing result with the methods that you used. That, I mean, was not possible a few years ago. And because I faced up a little bit the same problems, but same problem with more rudimental tools. I think it is very relevant because with your tools, you can really sort of extract what are the most important face parts and movements, even tiny movements, or I mean, small parts that elicit the response in the observer, in the human observer. So when you mix different facial expressions randomly, that's a very good way to understand what is really important for a human observer to understand an emotion instead of another one. And this is extremely relevant for designing robots, of course, building robots, and maybe it's also relevant to why Tom and Jerry looks more similar. So probably in the world of communication and cartoon, somehow they discovered how to make characters appear more realistic, or at least elicit the right reactions in the observers.
Yeah, exactly. And keep in mind that the approach that we use is totally generic. So if you have any measurable stimulus space and you have any response, it's been used in single neurons in primates, it's been used in anesthetized cats and their neurons, it's been used in pigeons, you can use it with button presses, physiological responses of different kinds. So it's a generic approach such that we could actually apply something like Bubbles to the Tom and Jerry versus Polar Express to find out what is it that makes these seem more realistic or enjoyable or something like that. It's quite possible that the differences between the two, the enjoyment of the two, could be to do with how expressive and comedic one is rather than the other one. So again, it's about what is the judgment that's being made that separates the two. But this is why the approach is so powerful, is that we could take, say, any agent of any form, and we can agnostically generate its movements to find out which one of those movements elicits the perception of, say, cuteness. If you want something to look cute, then what makes it look cute? What makes it look less uncanny? What makes it look more trustworthy within its particular realms of signaling? So it's a really generic approach that can be applied to any measurable stimulus space, and then almost any kind of response in any receiver, whether it's physiological or implicit, explicit, and so on.
Okay, so we're approaching the end of our time slot. I see Fumiya appearing, so maybe we have to wrap up. It was a very interesting combination of different viewpoints, I think. So thanks everybody for your contribution. I think we had already in the first session so many inspiring inputs, and I think the attendees and the roboticists there and those who are not roboticists will really gain a lot of inspiration for their work. So thanks from my side, and I pass over to Fumiya.
Yeah, thank you, Cecilia. This was a really wonderful panel sessions, and it touches upon many fundamental important questions of embodied intelligence. And this is a perfect start of the conference. Thank you for leading this discussion today.